Okay, so here we are solving check if array is sorted and rotated problem. So the problem statement says that given an array and we have to return true if the array was originally sorted in increasing order, then rotated some number of positions including 0. Otherwise we have to return false. So there could be some duplicates in the original array, and there's this node where an array rotated by x positions results in this thing. Okay, so what does this all mean? We have this example number 1 where the values are 3, 4, 5, 1, 2. So if you carefully observe, 3, 4, 5 are sorted and 1 and 2 are also sorted. So there is definitely a situation where this was initially sorted and now it was rotated. So we have to just confirm this, that whether this operation happened. So what would have happened here is initially this array would have been like 1, 2, 3, 4, 5, and then it would have been rotated, which would have resulted in this. So even if you read the explanation, initially it was this and the original sorted array in non-decreasing order, we can rotate at x equals to 2 position, which is this condition. Okay, when it was being rotated at x equals to 2, which is this, so from here these three elements came in front and 1 and 2 came at the last. So this is what this example is trying to explain us. Let's see the example number 2. So it says 2, 1, 3, 4. It's not a scenario where things are arranged in a sorted fashion, because had this been a good rotation, so then 2 should have been somewhere in between this, or 1 should have come before 2. So this is a false case. So there is no sorted array once rotated that can make nums, right? The third example says 1, 2, 3 already in the increasing order and there's no rotation happened, so we will be claiming true. The problem is difficult to understand, but there's definitely a pattern here. Also have a look over the constraint. So the constraint says the length of the number array would be from 1 to 100. Even the elements would be from 1 to 100. Okay, let's try to observe a pattern. Let's iterate manually. So if you see, 3 is less than 4 and 4 is less than 5, but 5 is greater than 1, which is okay for this situation. And then again 1 is less than 2. For 2, this element should be less than the array of 0, because its next would be coming to this point, right? Do you agree on this? So it's a cyclical manner. We are checking this value to be lesser than this, then 4 to be lesser than 5, then 5 to be lesser than 1. We are allowed one mistake here. So this is agreed. 1 is less than 2. This is okay. With whom do we have to compare the last value? So the last value needs to be compared with the first value. Getting this or not? Let's revisit in the next example. Here we have 2 and 1. So if you see, 2 is greater than 1, which is false, right? Which is first mistake, that is allowed. Now moving on, 1 is less than 3, that's okay. 3 is less than 4, that's okay. But 4, this should be less than 2. It is not less than 2, right? So in this case, are we able to identify some pattern here? There was one mistake which was allowed. Here, one mistake is already allowed, but it is making another mistake, which is the last value. Last value should be lesser than the first value, but it is greater than the first value. So this is where we can commit false. Okay, let's apply on the third example also. So here we have 1 which is less than 2, 2 which is less than 3, that's fine. 3, it's greater than 1, but it didn't committed any mistake as of now. So one mistake is allowed. Can we commit something? We can commit that, okay, we will maintain some counter which will check, okay, if the iteration has committed any mistake. If it's the first mistake, then it's okay. But if the total count of the mistakes is greater than 1, so this is the point where we can commit that, okay, this is a false scenario. Got it? So let's code this problem and stay tuned towards the end of this video, because again we'll explore ES6 way of solving this problem. So let's start. Approach 1. Here we will be we'll maintain a count and our count will point to 0, and what we will say is we will loop from first index. Okay, nums.length and iterate, and now we will be checking what we will be checking, if this value, current value, is it greater than the next. So since we have to check with the next one, we need to maintain some edge cases as well. So we need to confirm that I plus 1 is less than nums dot length, right? Because what if we are at this scenario, at the last case, we don't have any more elements after this, right? Now we need to check if nums of I greater than nums of I plus 1. If yes, what we were doing, if this is greater than 1, right? 5 is greater than 1. So in that case, we will be increasing our counter. And once the counter is increased and just coming out of this loop, as part of returning this, we can check. But before that, we need to check the second mistake. Nums of last index, nums dot length minus 1. Nums of the last index should be lesser than this, right? Should be lesser. In this case, it is greater. So if nums, let me write, if nums of nums dot length minus 1 is greater than nums of 0. So in that case, again, what we will do is we'll increase our count. And at last, before returning, we can simply check if my counter is less than or equals to 1. Okay, so let's test the custom test cases against our solution. It passes. And now let's try to submit this problem. Okay, so as promised, so now let's move on to the ES6 way of solving this problem. Comment this one. So approach 2. So approach 2 will not be different. It's just the syntax or the convention changes. With ES6, we can use a reducer. Okay, so we'll keep a const. This time I'm using a constant. Constant count is equals to, we'll do nums dot reduce. Okay, and the reducer basically accepts a callback function and a initial counter. Okay, so initially we will be passing the initial count as to be 0. Okay, now the reducer callback function actually expects 4 parameters, which are accumulator, current value, the current index, and the current array. So the current index and current array are optional to pass, but accumulator and current value, those are important. So we'll pass the accumulator. So accumulator would be storing this result. Let's suppose if we are doing a sum. So the accumulator will actually storing the sum of each number's iteration. Okay. And now we will be passing the current value, the current index. Okay. For ease, I'll name it I, okay, because then the code structure would be elongated. And current array I don't require as of now, since it is optional. We can actually replicate the entire condition over here, but this time I'll use the modulo operator. We'll do next value, because now we have to check for the next value. So when I'm on this index, right? So if I do I plus 1, we handled this over here by checking over the number's length, right? Now what we can do is, if ith value is greater than the numbers of length, we can wrap it up inside the array's length. How we will be doing that? If I plus 1, the current index plus 1, it's greater than the numbers dot length, modulo it with nums dot length, and okay, so this way it stays into that boundary, and now we can simply call the nums of this value as the next value. Okay, so assume we are at this point. Okay, 2, 0, 1, 2, 3 and 4. So 4 plus 1, 5. So 5 modulus length 5, which is 0. So it will go to nums of 0. Okay, we will be checking if our current value greater than my next value. Okay, so if it is greater, so this is the point where we can say, hey accumulator, please increase yourself because we found a mistake. So since we found a mistake, we updated that. If this check is not executed, so then also we need to return the accumulator, because the accumulator result needs to be updated with the value whatever is coming throughout the transactions. Okay, and now at last, similar to this, we can just copy this and we'll say if count is less than 1, So based on that, we can just return our answer. So let's check with the custom inputs. It passes. Let's submit this problem. Perfect. So two approaches. Probably the approach is same. So let's see what is the time complexity and space complexity for both. For the first approach, time complexity. So for this, since we are traversing just once, so the time complexity would be order of n, right? And what about the space complexity? The space complexity should be, so if you see here, we have order of 1, we just have one variable, iterators, and that's all. So order of 1. Okay, cool. So moving on in the next approach. So here we are actually doing this reduce operation. You can consider this thing to be a loop, and now it's actually reducing or traversing the entire loop and getting the things out of it. This entire thing is happening in order of n. This is similar to this, okay, the nums dot reduce. The time complexity again over here is order of n, and there's nothing down here. This is a order 1 operation, and this is also a order 1 operation, so we can commit that it's a order of n. And what about the space complexity? So the space complexity would be order of 1. Why? Because it doesn't create any space. So this is a order of 1, this is a order of 1. So whatever we are doing, that is a order of 1. We are not declaring a new memory set. So this is memory efficient. The time complexity and space complexity are same in both the scenarios. I still feel this is a bit difficult for the new developers or people who are new to JavaScript, but for algorithm wise, this should be easy and this should be very straightforward. So maybe you can present this solution to the interviewer, and the interviewer will also be happy with this one. So that's all. Thank you.